Okay, in today's video tutorial, we're going to learn how to detect light intensity and luminance while at the same time detecting color. On our previous video, we made a line following robot that could detect the green turns, the black line, and the silver strip. But it could only detect whether it was over the black or over the white. It couldn't detect how far on the black it was or how far on the white it was, so we could only make an on-off controller, which meant that it wiggled around quite a lot. If we can detect the intensity, or how much it's on the black or how much on the white, we can make a proportional controller. Okay, we have a little bit of code here. You guys should recognize it from the last lesson. All it simply does is set up the sensor to read RGB, and it actually reads it from the sensor and just writes that to the screen, just so we can simply have a look at the raw data. Now at the moment, it starts spitting out quite high numbers, and the camera focuses as well, and that would be expected because the robot is sitting over white. Then we move the robot over to black, of course, we get quite low numbers because black doesn't receive much. And when you have a look at this, you can understand white looks quite bright and black looks quite dark. The red to the eyes appears darker than the green. So one would expect the red will give quite low numbers and the green will give slightly higher numbers. The camera here doesn't actually do it justice. When we put it on the red, what you'll find is the red values we get, it obviously reflects a lot in the red channel, which is the first one. And you can see we get somewhere just under 300 on one and around a little over 260 on the other. When we shift him back onto the green, what you'll find is obviously the green channel gets the high reading, but we only get around 154 and 194, so much smaller. So this has to do with the difference between the way the color sensors see brightness, or the correct term reflected light intensity, and the way our eyes see brightness, or the correct term luminance. So if we want to adjust from the raw RGB data to the way our eyes perceive it, we need to work out the luminance. And if we want to see how the sensors see it, then we work out the reflected light intensity. Okay, I've just changed the code a little bit. I've added in a couple of lines to calculate the intensity of both the sensors, and it is just simply a third of the red channel plus a third of the green channel plus a third of the blue channel. But when I calculate luminacy, because our eyes perceive these different colors differently, we have different weights on them. And then just the last line down there, I'm just going to write it all to the screen. So when I press play up here, what you'll find is that the intensity is somewhere around about 100. And this here will focus nicely for us. The intensity is somewhere around about 100, but the luminacy is higher. That's because we're on the green, and to our eyes, the green appears much brighter. When I put it on the red is a darker color, so you'd expect the intensity to be less. But when we actually have a look here, the intensity is actually higher. So it's reflecting more light, but you'll notice that the luminacy has gone down since I shifted it. That's because our eyes perceive it to be less bright, but in reality, it's actually more bright. Okay, so I've updated my color detect routine where I've added these 4 lines in. The 2 lines where I work out the intensity for both sensors and the luminacy. So my subroutine not only works out the color, it now also works out the intensity and the luminacy. Now what I hear is my main program down here that used to detect what color it was on and steer. It still does the same with detecting the green and still does the same with detecting the silver, but now when it detects the black, instead of just steering by a certain amount based upon the light intensity, I steer proportionally, and I do the same with the other sensor as well. So I'm now steering proportionally based upon the intensity any time I get the color black being detected. Okay, here we are. Now hopefully when it goes around the course, it will go around smoother because the proportional controller instead of the on-off controller we had before. So when we see him go down the straight there, you see he goes down with much less wobble than what it did before. Proportional controllers still wobble a little bit, but they're generally far smoother than an on-off controller. He's still identifying all the turns, all the green signals, so he's now picking up colours as well as intensity.